our conference to the maximum of colleagues on Facebook,
Okay.
as well as Twitter.
اوكي سي محمد كاع
Oui, okay.
ولا صبرت نعطيهم الانطلاقه.
Okay.
اوكي الو ويس الزراعي عندنا صافي طلقت صافي يا بون سي محمد زوغاغ.
Okay. Good morning, everybody. All people connected via Facebook and YouTube. Let's begin this morning session with talk about analytical nanometrology from the characterization to the determination of nanomaterials. That will be presented by Professor Ángel Rios from University of Castilla la Mancha, Spain. It is an honor and great pleasure for me to present my colleague, friend, and boss, Professor Ángel Rios. Ángel is head of our research group in Spain on automation, simplification of analytical process, especially sample treatment, sensors, and screening method, miniaturization, and nanomaterial, developing metrology in chemical measurement and quality system in analytical laboratory. Ángel have published more than 330 articles in scientific journals with high impact factor. He has been involved in 45 research, national and international projects, and received several awards. For example, award for the Spanish Society of Analytical Chemistry, Antonio Hidalgo Award from Perkin-Elmer, distinction as relevant scientist from Castilla la Mancha region. Recently, he received award named Francisco Alvarez Award on Spectroscopy from the Spanish Society and applied spectroscopy, and other more. He was assistant editor of journal Analytical International Chemistry and was a member of editorial board of several journals. He has participated and expert in the evaluation of projects of the European, National and Regional Commission. Thank you very much, Professor Ángel, for accepting our invitation, and congratulations to all organization committee members for the excellent organization, especially for my good friends, Professor Hamouti, Zefali, and Touzani. Thank you very much, Professor Ángel, and you can begin the talk.
Okay, thank you very much, Dr. Zougagh. Kind presentation. Good morning, everybody. It's a great pleasure for me to present this keynote in the 4 international conference on
Sorry, Professor Ángel. Yes. We have no good quality.
Can you hear me well?
No, it's not good.
Can you hear me?
We have some interference. Perhaps.
Yes. Just find that previously. I don't know. Well, I can continue?
No, yes, okay. It's okay?
Okay, it's okay. Well,
Yeah, now yes.
Okay. Yes, well, yes, okay, perfect. Well, I told you it's a great pleasure for me to present this keynote in the 4th International Conference on Materials and Environmental Science, Morocco. I appreciate very much the invitation of the scientific committee and the organizer. My congratulations for this organization, and thank you very much, especially to Professor Hamuti. My talk deals with analytical nanometrology, therefore focus on nanomaterials in analytical chemistry field, and I will present this general overview illustrated with some example and research work that we have developed in our research group in University of Castilla la Mancha in Ciudad Real in Spain. I have organized my presentation following this point. First, an introduction about the meaning of this term, analytical nanometrology, and the importance of this way to measure a special material at this low size. And then I follow by the characterization aspect related with the nanomaterial, then the analytical nanometrology, and finally with some conclusion and some critical point of view. Well, what is nanometrology? Well, nanometrology is a new term introduced in order to associate the metrology, I mean the measurement science, applied to nanomaterial. So it is related with measurement and with nanomaterial. And from this point of view, the important development of nanoscience, nanometrology is an important aspect to take into account in order to consider the importance of this aspect in order to control the nanomaterial in different kinds of samples. Science and technology applied to nanomaterials is today consubstantial with the development and welfare of societies. For many years now, nanomaterials are receiving more and more attention. The eyes have been directed to the nano world, and thus nanoscience and nanotechnologies emerge as an increasing important trend. But why the interest of the nano world, and in particular of the nanomaterial? Well, because the properties at the nanoscale level in this material are different, and sometimes very different than the properties presented by the bulk analog materials. We consider, and it's considered, that the nanoscale level correspond to nanomaterial having a size lower than 100 nanometer. And these exceptional properties of nanomaterial are associated to mainly two things: the reduction of the particle size, of course, this is the first requirement, but also by the increase of the surface volume, the important increase of the surface volume ratio, and is introduce a very high specific surface in order to interactionate with many other compounds. And this is due to the so-called quantum side effect. Due to this effect, by the important reduction of the sign, it is created new discrete quantum state of energy, and this introduced the main chain of this nanomaterial with a more reactive surface and a high number of atoms in the surface with increased reactivity. Some example of this different situation from the typical size than the nano size can you see in this slide. For instance, the electronic conductivity of carbon, depending of the way of the material. For instance, if we take as reference the graphite as one unique as electric conductivity. For the fullerene is 100, and for carbon nanotube 1 million. So this is important increasement, and it is clear the differences of the nanomaterial with respect the analog of bull material of normal length of side. Also, the particular property presented by some metallic nanoparticles such as gold or silver nanoparticle and package for humidity protection and higher thermic and chemical stabilities are well interesting property associated to the conservation of the food. Or now the encapsulation of nanopharmaceutical compound in order to avoid the toxicity side effect in living organisms. So a very clear example of this difference of the property when the material is presented in the nano side. There are a wide variety of nanomaterials, and it is possible to classify them according to different criteria, as you can see in this slide. From inorganic nanomaterial, organic, combination of both in different ways, etc. But more important, the nanomaterial now today are involved in almost all fields of the human activity. For instance, in the textile industry, in the material to produce new green energies, for instance, or the cosmetic, environmental, of course, in the food industry and also in the agriculture, in the medicine. So it's very important the use of this nanomaterial and very wide developed around the world. So the main thing is the characterization of this nanomaterial in order to know the properties and also the characteristic of this nanomaterial. So let me first to show you the situation for the information related to the nanomaterials. In fact, it's very difficult to obtain a full or complete information about nanomaterial because there are a lot of information associated to this compound. Of course, the first one is the size, and more important perhaps the size distribution of the particular nanomaterial, but also the level of agglomeration, the shape, the structure, the composition, the surface, the characteristic of the surface, and of course the concentration from an analytical point of view. I would like to consider this wide variety of information from 2 points of view, according to consider the nanomaterial as samples, I mean as material we need to characterize in order to be used later in other application, in other use in different fields, and even as analytical tools. And the second side is the consideration of nanomaterial as analyte. This the objective of analytical work. So it means the determination, the analysis of sample containing target nanomaterial. And this focus perfectly with the term analytical nanometrology I defined previously. So we can use many of analytical techniques in order to perform this characteristic of the nanomaterial, the characterization, especially when we consider a sample. For instance, it's very important the role of microscopic technique, transmission electron microscopy or scanning electron microscopy, in order to obtain information about the morphology, the size distribution, the level of agglomeration, or the shape of the different nanomaterial, especially nanoparticles, but also diffraction technique like X-ray diffraction, in order to know the crystalline structure and also the composition of the structure of this nanomaterial in combination also with spectroscopic techniques such as Raman spectroscopy, surface enhanced Raman spectroscopy, or Fourier transform infrared spectroscopy in order to know the structure, the composition of this nanomaterial. But in all these cases, normally we need to have the nanomaterial in solid state. And in many cases, it's important to know the characteristic of the nanomaterial in liquid phase, especially in aqueous phase, in aqueous medium. So in this case, it's very useful, for instance, the use of dynamic light scattering in order to know the size distribution of the nanomaterial. In this case, from a hydrodynamic point of view, I mean in solution, and also to know the charge, the setup potential of this nanomaterial. So dynamic light scattering in this case is very interesting technique. And also, of course, the spectroscopic techniques such as UV fluorescence in order to know the different size of, for instance, quantum dots, as you have in the slide, of different size, present different color or different properties, is very important. But it is also in this liquid phase the role of instrumental separation technique, especially hyphenated technique, involve, for instance, hydrodynamic chromatography, size exclusion chromatography, capillary electrophoresis, or more recently, field flow fractionation technique. So this is an important analytical tool in order to obtain information about nanomaterial in liquid, in aqueous media. Let me show you some example of the importance of the good characterization of nanomaterial in use, in this case, for analytical purpose. It corresponds to the classification I give you before about to consider nanomaterial as sample, and this, in this case, as analytical tool in order to develop different analytical methodology. And in this case, for instance, for the development of electrochemical sensing device, for instance, for the modification of screen printing carbon electrode and the determination of antigen in full sample by using the synthesis, of course, of aluminum doped titanium dioxide nanoparticle in order to modify the screen printed carbon electrode. Of course, it's important the good characterization of this nanomaterial in order to have reproducibility between different batches. And you can see here in this slide the information provided by a microscopic technique in order to check the introduction of titanium dioxide nanoparticle in aluminum nanoparticle, and also X-ray diffraction in order to check in the recording the characteristic band of this characteristic peak of this nanomaterial incorporate in the aluminum nanoparticle. The incorporation or the modification of the screen printed electrode is very easy, as you can see in the illustration in the slides, for the determination in this case of antigen in different type of sample, food sample, and the corresponding electrochemical recording in order to perform the determination. Also, another example of the modification of screen printed electrode is the modification with copper selenide nanoparticle on aluminum to determine L-tyrosine in different kind of pharmaceutical sample. Also, the characterization of the nanoparticle, as you can see in this slide, by scanning electron microscopy, and also by X-ray diffraction in order to check the incorporation to the copper selenide nanoparticle to the aluminum nanoparticle. And also the corresponding electrochemical recording in order to perform the specific determination of L-tyrosine. But the main challenge today is, of course, not only this characterization, this simple characterization of nanomaterial that are going to be used later on in another application, as I showed you before, for instance, for analytical purpose, but the main challenge today is the proper control, analytical control, determination of nanomaterial in a specific type of sample, as I point out recently in a review published in Analytica Chimica after discussing about the main present achievement and also the important challenge we have just in the development of analytical nanometrology with the objectives of determine specific nanomaterials in a specific type of samples. Let me show some examples we have developed, for instance, in this case, and the first example, a simplified approach we have developed for the screening of silver nanoparticle in pastry samples. Silver nanoparticle enhance the quality, safety, and shelf life of packaged food and drink due to the antibacterial properties, but they pose potential health risks which are still far from being clarified and consequently regulated. An interesting case is this I show you now in the slide, is that the silver color pairs, which include metallic silver, also known as additive E174 in the European Union as a recognized and permitted additive. The problem is the size. When it is present in nanophore, in nanoparticle of silver nanoparticle, the problem is perhaps associated with some problem with toxicity of this nanoparticle by migration to the food. This is an important social concern today, and the development of rapid screening method in order to check the amount of silver nanoparticle in food sample is an important objective. So we have developed this screening method by combining a chemiluminescent check based on the reaction with luminol in order to check the presence of silver nanoparticle, because the specific effect produced in this luminescent effect. And then we confirm the presence and the size, the average size of the silver nanoparticle by using field flow asymmetric fractionation combined with ICP and mass in order to know the presence, to confirm the presence of silver nanoparticle in the supernatant, for instance, and also the average of the size of this nanoparticle. But also, let me show you two interesting examples applied to food field in order to control and to have information about two important nanoparticles which can be present in different types of food sample. The first one is the analysis of silica nanoparticle by a method we have developed by the combination, the accoplation of capillary electrophoresis with evaporative light scattering detection. In this case, the nanoparticle, silica nanoparticle, is a European authorized food additive. It is the E551 additive, and the maximum level permitted depend on the type of the matrix. You have in the slide an example, for instance, 50 grams per kilogram for dry powder preparation of emulsion and in flavoring, for instance, or 10 grams per kilogram in nutrients preparation for food for infant and young children. The problem is, well, this is a permitted additive, but the European legislation doesn't specify the size of this material, of this additive. And the problem is that some studies conducted to some potential risks in a specific case, for instance, can present a pregnancy complication or problem with the coagulation of the blood. So it is important to develop a method. This was our objective some years ago in order to control this nanoparticle in food. For instance, the presence of this nanoparticle in salt sample. We use in this case capillary electrophoresis coupled with evaporative light scattering detection in order, as you can see in the recording, to separate the different size of silica nanoparticle with very good resolution, as you can see in the left side of the recording, in order to check the presence of nanoparticle of different size. And of course, it's possible to have some information about also the presence of macro particle of this compound. But the objective is to check the presence or no of silica nanoparticle in sample, in this case, salt sample, as you can see in the application, in the recording, the first one. In the top is the salt sample without this nanoparticle, and the second case, the presence of silica nanoparticle in the second sample, in the second recording. It's important to say that the sensitivity of the method is adequate for the level of the legislation, for instance. Another interesting example is the control of titanium dioxide nanoparticle. Titanium dioxide is a compound present in many fields of human activity, in many industries, for instance, in cosmetic, in ceramic industry, also used in biomedical application, or as a catalyst, etc. And important in food industries. In fact, it's a food grade additive. It's the additive in European Union E171, and the problem again is it is legislated the maximum level, but not consider the form of the presentation of this material in the sample. And it is demonstrated recently that when the size of this compound is very low at nano level size, it's possible the penetration of titanium nanoparticle through the cellular membrane, and even to be incorporated in the nuclei of the cell. And this is an important problem because it can modify the DNA and produce important change. In fact, it is considered now titanium dioxide nanoparticle as a cytotoxic, genotoxic, and carcinogenic agent. And a good proof of this problem associated with the human health is the famous company Donus some time ago in 2017 announced that company removed the titanium dioxide of the sugar added to the famous donut food. And we have developed in this way a screening confirmation method in order to give information about the presence of titanium dioxide nanoparticle in food sample. Involved three main steps. The first one is the confirmation of the target material, in this case titanium dioxide, in the sample. But the second step is the confirmation if the presence of titanium dioxide is in fact as nanomaterial, it means at a size lower than 100 nanometer. And the third step is the additional information in order to confirm the presence of this nanomaterial in sample. For this purpose, we developed a method combining the screening by using Raman spectroscopy. In this case, it's possible to detect the presence of titanium dioxide in the sample, even to distinguish between the different crystalline structure as anatas or rutil, based on the different Raman band we can check in order to have this information. So we have the positive response that the titanium dioxide is present in Zougagh sample. We confirm just is in nanophore by using, in this case, capillary electrophoresis coupled to evaporative light scattering detection. You can see in this slide have the recording, the electrophoretic recording of for the confirmation of the presence of titanium dioxide nanoparticle in food sample, in Zougagh sample, the characteristic peak for rutil and anatas, and also it's possible to check the presence of rutil, but in higher size of the particle. Using this methodology, it's possible to analyze a sample, in this case, Zougagh sample. It's possible to check, as you can see in this slide, the absence of this nanoparticle in the first sample, S1, or the presence of silica nanoparticle in the second one. So it's important just the control of this nanomaterial in food sample. I want to remark also the important role played by ICP-MS spectroscopy, especially in the mode of single particle ICP, in order to give information in the general framework of analytical nanometrology. This technique, this single particle ICP-MS, provides information about the single particle arrived to the detection system. For instance, every nanoparticle reached to the detector corresponds to one pulse in the recording, and the number of pulses is directly proportional to the concentration of the nanoparticle in this case, and also the intensity of the pulse can be related to the size of nanoparticle. In fact, this technique offers interesting feature because it's allowed to differentiate between ionic and particulate signal without any prior separation, is very sensitive, very selective, and it provides very interesting information about the amount of nanoparticle in the sample, and also the size distribution of this nanoparticle. We have developed in this line and nanometrological strategy for the screening and confirmation of titanium dioxide nanoparticle, now in this case in human care product, by using just this technique that you can see in this slide. In this case, the capillary electrophoresis method allows the screening of the titanium dioxide in the sample, and then the confirmation after the isolation of the sample, the component in the sample, of the size of the nanoparticle present in the sample, as you can see in the right side of the slide. Well, more and more, the interest for organic nanomaterial is increasing because nanostructured organic nanomaterial are used for encapsulation or nano-encapsulation of compounds of biological interest in form of nanoemulsion, nanoliposome, nanomicelle, or the use of nanocarrier. So we have recently published one word for the discrimination of nanocurcumin and free curcumin in nutraceutical formulation. This aspect is very important because curcumin is a lipophilic compound with substantial health benefit, but it is characterized by a poor aqueous solubility and thus low bioavailability and high instability or degradation under light radiation. And thus this aspect limit their benefit, of course, because the poor assimilation by the body. Its encapsulation into nanostructure, for instance, nanomicelle in our case, avoid the use this inconvenience and provide the permeation and penetration into the body. The method we have developed is based in the different behavior of curcumin and nanocurcumin in the interaction with graphene, the fluorescence presented by the graphene quantum dot, and in this case the different behavior with respect the quenching effect presented by both compounds. So it's possible the discrimination between both for nanocurcumin and curcumin, and this is important for the control in a specific type of sample, nutraceutical, for instance, product, in order to check the way to be better assimilated by the body. Well, as conclusion, I can see more and more nanomaterial are used in almost all fields of human activity. So this is a clear fact today. And of course, it offers interesting usefulness for many applications, but this important use in this field must be balanced with aspects related to toxicity or environmental pollution, for instance. In fact, it is recognized there is a disproportion between the investment dedicated to development of new nanomaterial with respect that it is dedicated to studies related to the safety of this product. And of course, they offer interesting opportunity, the incorporation in our field, in analytical field, as analytical tool in order to develop new, more advantageous methods of analysis. And of course, there are an important interest to develop the so-called analytical nanometrology in a reliable way today. But of course, it's necessary to recognize we have important challenges in this line because it's necessary important development of analytical metrology, nanometrology, not only based in the physical information about the characteristic of the nano material, but also chemical information about the nanomaterial. But we have important bottleneck for the usefulness to the end use of analytical nanometrology. I mean, important challenge in order to transfer the research method developed in the laboratories, research laboratory, to routine control analytical laboratories. The main aspect to be focused are first, the identification of real problem, in which nanocomponents are present in a specific sample, and they may be a problem from different point of view. So the identification of this problem. Also, important problem associated to the sample preparation, sample treatment, in order to assure the integrity of the nanocomponent when they are detected by the equipment in the analytical method. It's necessary to promote the development of a screening system in order to give rapid information about the presence or no of the present nanoparticle in a specific sample, the need to develop reliable standard, and also quality assurance program for the validation of nanomaterial method. And well, finally, I would like to thank, of course, all my group in Ciudad Real, in Córdoba, sorry, in Spain, in Castilla la Mancha. You can see a picture of the person involved in all this war, and also another person are not present in the picture, but you have the relation of the person in the right side, and also international collaboration, for instance, with Professor Zougagh in Morocco, and also thanks to financiation from the different body, from the national body, regional body, and of course, all of you. Thank you very much for your attention. Thank
you. Thank you very much, Professor Angel Rios, for this very interesting talk, perhaps about actually we are living one pandemic. Perhaps it is very interesting to developing some screening method in order to control this pandemic. Now we open session for question.
Please, I have question.
You have question?
Yeah.
Okay, Professor Nawi, okay?
Yes, thank you very much, and thank you for this excellent talk. And by seeing your huge work, I just see the potential of cooperation between Morocco and Spain to share the experience. We have a lot of young students and scientists. They can cooperate and to go to Spain, and Spain come to Morocco to make a huge cooperation. That's the first thing I can remark here. And my questions is about this new pandemic. And I wrote already in the questionnaire this questions, what I want to read again. Do you have any new research project regarding drug delivery to avoid increase viral load among COVID-infected people? Since, you know, nanomedicine involved the use of nanocarrier as a delivery system for drug or gene for maximizing the therapeutic effect. As you know, this virus, the coronavirus, is a very small stuff which go inside the cell, and it's also possible that the nanoparticle can do the same and interfere with this kind of virus. I'm not a doctor, but I just try to imagine stuff. And do you think it's possible to have a kind of project in the future which is in parallel with the vaccine, that it's possible as soon as someone has the virus to deliver some drug nanoparticle in order to stop the viral charge, the viral load, etc., in this direction? Do you think something like this?
Yes. Thank you, Professor Renawi. Yes, I agree. This is a good question because the use of nanocarrier are an important tool and trend in order to introduce drug, for instance, in the body, in order to avoid secondary effects, for instance, and to reach just the problem in the body, tumor, for instance, or another location in the body in order to solve the health problem. And there is some work developed not with virus, but with bacteria in order to promote the action of a specific bacteria by using nanocarrier. So I suppose it's possible also to address the research work in the future in order to study the interaction with virus of this nanocarrier in order to conduct the drug, for instance, in order to treat this disease produced by the coronavirus. And well, I think it's a good orientation of the research work by using especially nanocarrier, nano-encapsulated drug in order to present an efficient effect of this virus disease. So I think this is an interesting objective for the future. And of course, you mentioned the collaboration between Morocco and our group. Well, it's important also this collaboration because I think we share important experience, and also we have complementary work that we can meet and develop new interesting develop in research field. So I think it's good selection, the combination of the work of research in different part of the world, and especially in this case, we have very good collaboration with Morocco, as you know, and we are good friends, Professor Zougagh, Hamouti, and many other research person in Morocco. So thank you. We think it's important, this collaboration.
Any question, please?
Other question, yes?
Please, Zougagh. Another
Okay,
question?
Zougagh. Okay.
Thank you very much, Professor Angel Rios, and for your great collaboration, and also for organizing committee, Professor Hamouti, Rashid Touzani, and Fouaz. My first question is asked by Professor Inawi. My second question is about, can the nanomaterials be used in developing vaccine and therapeutics? Thank you.
Well,
okay.
Yes, I understand it's to develop vaccine based on nanoparticle, nanomaterials.
Yes.
Well, I am not an expert in this field, but I think it's a good subject, as I commented before, because I think the use of nanomaterial and the encapsulation of many of compound, the nano-encapsulation can produce interesting effect in the treatment of many diseases, I think. And of course, I don't have many information about it, but maybe in a good trend in order to produce another way to treat this disease. Of course, I am sure it's interesting to follow this research line, because the problem we have today with this type of disease, especially this pandemic with the coronavirus, I think so. It's a good address, a good objective in the future.
Okay. Professor Mamia Al-Ghazi.
Good morning. Thank you very much. Thank you very much, Professor Rios, for this nice talk. I have two questions. Just comment before virus. There is a lot of
Please, Professor Ghazi, we have no good connection. Please, all we can disactivate the microphone, okay?
Okay.
Okay,
And
now it's good, okay? You have interference.
Okay, just to thanks Professor Rios for this excellent conference. I have only one comment about viruses. There is a lot of work about conducting polymers and gold nanoparticle on screen printed electrode for detection of virus. The main problem is to work with virus and COVID. You should or you must have cooperation between laboratory, and here in Morocco it's very difficult if you as a researcher in pathology to have ERN or antigen, what you call antigen, to develop the sensors, but it can be done. I think there is a lot of idea. I think this can be done, and electrochemical method can help in the sense of selectivity and also the rapidity. We need only short time. I want to ask also a question for Professor Rios about the preparation of aluminium nanoparticles. I saw that they use chemical mode, and I think it's a very long time to prepare aluminium nanoparticle this way. Do you try to use electrochemical method to prepare your nanoparticle, aluminium nanoparticle? Thank you, Professor.
Is what in fact we have developed some method I show you using aluminium nanoparticle, even modified with another nanoparticle in order to be included in screen printed electrode, carbon electrode. So it's not difficult. It's a normal synthesis of this nanoparticle without many difficulties. So, and the incorporation to the screen printed electrode is very easy because, as you can see in the illustration, it's simple. A suspension of this nanoparticle by a micropipette to be introduced in the working part of the electrode. So it's not difficult, and I completely agree with you. That is very important. This kind of electrochemical sensor are very important because are very sensitive for many compounds. If you properly select the modification of the electrode, and of course is a fast response. So these two very interesting advantages or characteristics of this type of sensor, microsensor, because it combines very good selectivity and very good sensitivity, and you have the information very quick. It's rapid response. So I agree in this aspect with you. And well, about the synthesis of the aluminium nanoparticle modified with another compound or nanoparticle, well, we have information. If you like, we can send you the specific way to do that. And of course, it will be a pleasure to send you.
Okay, thank you. More question, Professor?
May I ask a question? May I ask a question?
Sumiata, okay?
Thank you, Professor Rios, for very nice lecture. Even non-specialists could learn a lot from it. I have one question and one comment. Do you believe that it would be possible to reinforce somehow cellular membrane to be more by nanoparticles to make it more resistant to the viral infections? It is a question, and the comments concern the metrology. Physicists for physicists, it is enough to measure something effectively. For example, very small quantities or very small objects. But for legal metrologists, it is not enough. It is necessary to have very reliable standards, to have somehow consistency, traceability, metrological traceability. And it was a lot of problems with this, but now it's better after redefinition of System International. Even it was a problem with mass because we had very old standard of kilogram, yes, and how to measure nanokilograms. But now it is possible because there is no kilogram standard. This is just some kind of procedure and relation to the physical constants. In case of mass, to the Planck constant, but not only. And we can make micro balances, word balances, and to make, for example, the standard for nanomass metrology. It is just a comment, but my question was about this reinforcement of the cellular membrane by nanoparticles. Is it possible or not? Okay, I just wonder. Thank you.
Thank you, Professor Sumiata. Well, the two things important. Of course, I remark at the end of my lecture just the problem related with the development of analytical nanometrology related to the availability of standard, of course, from a metrological point of view. It's clear. But we have to develop an important effort in this way because there are very few standards. And of course, we are working just in this aspect for a specific application. For instance, the development of titanium dioxide certified reference material in collaboration with the National Center of Metrology in Spain, because this is important task, of course. Even perhaps you mentioned the kilogram, no, the physical measurement. In fact, we need in chemical measurement a different approach sometimes, and even the definition of traceability, if you remember, was modified yet in order to refer the reliability and the traceability of the measurement to establish a reference in order to avoid from a chemical point of view, for instance, but also in biology, in accounting, in microbiology, etc. So another different reference in order to be compared and to give reliability to the measure. So perhaps also the use of some reference method for some particular application of the determination of nanomaterial and a specific sample can be another alternative. So I think we have a lot of things to do in this line, in chemical analytical nanometrology, because in fact today we have a lot of deficiencies, a lot of problem to develop reliable information, and this is important, of course, because then we have to adopt a decision, important decision affecting to the society and to the companies, etc. Of course, I agree with you. It's important all the four in this line, and related to to remark the cellular membrane in order to avoid the penetration of virus, bacteria, etc. Well, I think is also an important subject, and I don't have many information about it, but I suppose maybe possible because some I mentioned before the work developed with bacteria. This is also possible to avoid the penetration of bacteria with that specific nanomaterial. So we don't work, of course, in this line, but I think it's an important subject, and I am sure it's possible to develop some carrier in order to put in the surface of the membrane some nanoparticle in order to avoid the penetration of virus, for instance. Very, very important. Yes, I think it's an important subject, of course.
Muchas gracias, professor.
Okay.
De nada.
Other question? Okay.
Yes, it's Mohammed.
Okay.
Tuzani.
Yes, Tuzani, sí, Professor Tuzani. Okay.
Thank you so much, Professor Angel, for this nice conference. I saw also this opportunity, ICMES 2020, is an opportunity and challenge for young students. As you are the head of your group and participate in European projects and national projects, and I think we should incorporate PhD students like Erasmus fellowship and European projects to support young students, because in Morocco we have a lot of excellent young students can have the chance to deal with these nanoparticles. We grateful for your support and help. Thanks a lot.
Okay, thank you, Professor Tuzani. Yes, we are open to collaborate, of course, and we have good example with the young student coming from Professor Zougagh, excellent student, and we develop even interesting PhD work. So we are open. I think this collaboration is important, and we can, of course, to discuss the term of this interchange of study. No problem.
Thanks a lot.
Okay. We have a question via Facebook. Professor Hamouti. One moment, please. Professor Hamouti, you can read the question via Facebook?
Yes, from the student Beniz Erdak. Please think about cooperation with Moroccan skills to work in those projects.
Okay, it's not a question. Okay, is some information? No.
Yes.
Mm-hmm.
Okay, thank you very much for your commentary. Okay, if we have not more question, we can close.
I have one. If you
okay. Sorry.
Yeah.
Okay.
So
okay. Professor Nawi.
Yes, we last few years I work on nanoparticles, but for a specific subject is for solar materials, and there are two kinds of material we struggle with problems. One is the binary and ternary compound for solar cell to prepare nanoparticles and controlling the size of nanoparticles. And the only way we have to control the size is to use some ligand, some additive, which is based on carbon, like olelamine, for example. But the problem is the nanoparticle contain too much carbon, and when we are annealing in order to get the compact film, the carbon still in the matrix. Fortunately, somehow the carbon go to the back contact, but a lot of carbon stay inside the bulk and disturb the electronic properties. So that's one of the problem, that we cannot make a good solar cell starting from nanoparticles. And the first question is, if you think that there are some ligand or some possibility to make nanoparticle where we can, from one side, we control the size of nanoparticle. On the other side, we avoid carbon. So some ligand without carbon, that's one question. The second problem we are struggling, and this is a very interesting, is 2D material, two-dimensional material. Is it possible to make nanoparticles with two-dimensional material where we can grow the nanoparticle only in one dimension, in lateral dimension, not in the bulk? For example, to make two-dimensional material with two monolayer or three monolayer, so we control not the size of the particle, but the monolayers. Do you think it's possible to have a strategy for that? That's the two struggling what we had, and we still have now. Thank you.
Okay, thank you, Professor Enawi. In fact, we are no expert in the synthesis. We take some information from the bibliography in order to develop our method. So in some time we control, according to the special procedure, the size or even the shape of the nanoparticle. For instance, for gold nanoparticle, rock nanoparticle, or triangle nanoparticle. I don't know exactly the way to control exactly in a general way the size of particular special nanoparticle. I don't know if Dr. Zougagh, because it's my college and is also know very well this thing, have some additional information or some specific information about the control, the specific control of the size, and also how to remove this carbon nanoparticle or particle from the material to develop solar cells. Yeah, I don't know if Dr. Zougagh has some information about that.
Okay, just in our specialty is not in organic team in order to synthesis some specific material, for in your case in solar block, but we just use some previously developed material and not complicate in order to develop a tool. Perhaps it is possible, but I have not information about controlling the synthesis because we are an analytical team and we have not experience and specialty in this team. Just we synthesize some described nanomaterial previously in bibliography in order to use it to develop a new analytical method. Okay. More question?
So thank you.
Thank you.
Thank you.
Okay. If we have no more question, we can close this session. And thank you very much. Thank you so much, Professor Rios and all organization committee. Thank you very much.
Thank you, all of you. Thank you very much.
Thank you so much.
Thank you.
And have you a nice day.
Have a nice day.
Nice day. وصافي سي حموتي ياه
الله تبارك الله عليكم، يوم مبارك.